Good morning, children. As I have already taught you, chapter 1, forces, turning forces and uniform circular motion. Today I am going to, because I have explained all the topics of this chapter, therefore, today I am going to tell you the numericals of this chapter. So carefully see how the numericals are solved of this chapter. So practice problem 1. First I am going to do practice problem 1 and which is given on page number, the book is old one, so it is, I don't know in your new book which page number this problem is given, but in my book it is given on page number 12. This is the old one, page number 12. So first question they are saying, children listen carefully to the question. A force of 50 times. As you read, write down what are the things given. So given here, force F 50 times. 50 times. Then children, such that the perpendicular distance between the fulcrum and the point of application of force 75 centimeter means this is the line perpendicular distance between the line of action of force and axis of rotation. What is that given? It is given here 75 centimeter. So we can see that times centimeter, these are all in CGS system. Therefore our answer also will be in CGS system. What they have said, if I show you by a diagram drawn here, that a force is applied here 50 times and the perpendicular distance between the point of application is not that, but is the perpendicular distance between the line of action of force and the axis of rotation that has been given as 75 centimeter. So what is the moment of force? Calculate the moment of force they have asked me. Moment of force. It is denoted by tau. This they have asked. If you know the formula, then you can easily solve it. All the things are given. You can write here, we know moment of force tau is equal to force into perpendicular distance between the line of action of force, and axis of rotation. So both the things are given here. Force given 59 and perpendicular distance given 75. So multiply children by 5 to multiply by further 25 to carry 35 plus 6 37 3 7 5 and this 0 keep here, and this is because moment of force, so dyne centimeter. In CGS system, unit of moment of force is dyne centimeter, and that is the required answer. Very simple children, very simple, and you can easily do all these type of questions easily. One question that has to be done of a couple. See, when a couple is given, because this is of moment of force, couple I told you, two equal and opposite forces whose line of actions are different. So form a couple. I wanted to do for you PP3 practice problem 3, which is given in my book on page number 13. See, you are having the new book, so the page number can be different in your book. In my book it is page number 13. Written, calculate the length of arm of couple. Couple, think of the couple. And children, two equal and opposite forces. Two equal and opposite forces are acting on it. Because it's a couple. Force of written 13 Newton. 13 Newton produces a moment of couple written. This is practice problem 3, question number 2 I am putting children for you. Moment of couple, if I say ask you, can you state the formula? Moment of couple children, either force also can be pronounced as either force and into arm of couple. Children, when I am talking about either force or either force, that means we are not going to take both of them. 13, 13, 26 don't take children. Only one, 13. Either this or that. See, either force into arm of couple. And in this question, length of the arm of couple has been asked. So, moment of couple given 14.3. 14.3 Newton meter. Remember, this is SI unit. And then 13 Newton is also SI. So our answer will be coming in SI unit. And you know, arm of couple is actually the distance. So that is why its unit will be meter in SI unit. So arm of couple write down here. Or you can say 14.3 upon 13, arm of couple. And what is it? Therefore, arm of couple, if I divide 13 ones are 13, 1 left out, then decimal. So keep a decimal here. And then 3, 13 ones are 30, and it will be in meters. That is the required answer. Now children, the question which has impressed me, and this is important one also, PP practice problem 6. In my book it is given on page number 15. It is on the uniform meter scale. Children, why? Okay, I am doing for you with diagram. When I will do for you, then you will understand in a better way. See, uniform meter scale. One side I will be doing 0 and one side 100. Children, why I am going to say it every time? Uniform meter scale. I can also say it meter scale. 100 centimeter length. I can say meter scale. Why we are saying uniform meter scale? There is a reason behind. Here, the CG that is working, CG is at the center of gravity is at the midpoint of the meter scale. If the rod is uniform, like uniform thickness is there, then the center of gravity is at the midpoint. So the whole weight of the body is supposed to act from this point, means 50 centimeter. Then a uniform meter scale balances horizontally on a knife edge placed at 55 centimeter mark. Whenever knife edge written, or even if it is written that it is balanced at this point, there you will draw this type of triangle known as the knife edge here, and in this question it is placed at 55 centimeter. Children, remember that we will calculate the moment about this point. Center of gravity is okay. Center of gravity is where the whole weight of the body acts. But from where we are going to calculate? Question is this, and we will always take the distance from here. Means here now this distance is 5 centimeter there. So the 55 centimeter mark, when it rests, when a mass of 25 gram is supported from one end. Now this is balanced. They are saying that from one end, 25 gram is supported from one end. 25 gram is supported from one end. Can you tell me, children? Which end? This and that end. They have not said it. In this question, they have only mentioned that from one end 25 gram weight is acting. If I keep this, if I consider this end, you know that it will not be a balanced one. Why? Because both the forces are on one side. So you have to say that 25 gram force here is acting from the 100 centimeter mark. Here the mass is given, so they have used only 25 gram. Remember that moment is force into perpendicular distance between the line of action of force and axis of rotation, not mass. So whenever mass given, gram written, mass, we have to multiply it by g, small g. Gravitational acceleration, which is 9.8 meter per second square as average we take. Children, so 55, but we have to write all these things. We cannot say everything verbally here. So question number, this is of practice problem 6. Practice problem, okay, I am writing completely for you because I have a habit of now saying EP6 instead of practice problem. Practice problem 6. In my book, it is given on page number 15. Let's then write here only. I've already written here. Let's write here, children. Practice problem 6 and page number 15. But first I have to write this. This is question number 3. You will write, since due to its own weight, mass of the scale has been asked. Mass of the scale has been asked here. I am writing it. Due to its own weight, the ACW moment is more. Its own weight means here the meter scale's weight is supposed to act from the midpoint of the uniform rod, that is here 50 centimeter. Due to its own weight, you can write in your own words. The anti-clockwise moment is more than the clockwise moment. Then the clockwise moment. Therefore, 25 gram mass must be placed or must be suspended. Write down suspended from 100 centimeter mark to balance the meter scale. Due to its own weight, the anti-clockwise moment is more than the clockwise moment. Therefore, 25 gram mass must be placed from 100 centimeter mark to balance the meter scale. Let mass of meter scale be mass of meter scale. We are writing it representing by mm. We know by the principle of moments at equilibrium, balance state, at equilibrium, anti-clockwise moment is equal to clockwise moment. So, what I am going to write now, that anti-clockwise moment, if I am doing, this weight, this mass of the meter scale, actually we will consider the weight only, is producing the anti-clockwise moment. So what I am going to write, mass of meter scale, but write it G. Why? Because make it weight, force, gravitational force here. So mm into G into what is the distance here, 55 minus 50, means 55 minus 50 you can write is equal to 25 into G. Mass is here 25 gram. This is gram. This G is representing gram, and I am writing this G as gravitational acceleration into what is the distance. Again, always consider the distance from the knife edge. What is the distance here? 100 minus 55. Or you can say mm into G into 5 is equal to 25 into G into, it is 45. Last two lines. Children, G and G cancelled because this will come this side. You know that it will be in the denominator side, so it will be cancelled. Then mm, mass of the meter scale, will be 25 into 45 upon this 5. You cancel 9 times, 25 9 25 grams. The required answer. Therefore, you can write answer, the mass of the meter scale. The required mass of the meter scale is 225 grams. So, we have discussed today about the numericals of this chapter, and other questions are also of similar types. You can now practice at your home. And now we will go to the second chapter, work, power and energy. For today, I am ending the session. Bye bye.